Hi everyone, this is Yong Xu from Microservices Asia. Here I'm glad to introduce our work, TraceLingo, a new trace representation for performance issue diagnosis in cloud services on behalf of our team. Nowadays, more and more applications are moving to cloud to provide online service for customers. And performance is significantly important for customer satisfaction. For example, the cloud platform like Azure saw millions of VM creation requests, and long delay in VM provisioning would definitely impact customer experience and business revenue. Therefore, fast detecting performance anomaly and accurately localizing the bottleneck is critical to guarantee service quality. The distributed traces, which record the detailed execution flow, provide important information for monitoring the service performance status, identifying anomalous requests, and localizing the root cause functions. Here is an example of VM creation scenario. There are many different modules when processing VM creation tasks, like preparing disk, connecting network, and etc. And each module has multiple sub-functions within it. The middle shows an exemplary trace data during the process. Each record logs the information of one call function, what we call span, with the relative running information like span name, the hosting server, the parent span ID, the root span ID, timestamp, duration, etc. And based on this detailed information, a call tree can be built to represent a trace. Note that the execution flows may vary because they are executed on heterogeneous contexts like different hardware generations, OS types, and there are also new updates on applications. To automatically and effectively locate the anomalous traces and bottleneck spans, there's already a bunch of work on trace analysis, and they can be divided into three categories: the metric-based, sequential-based, and graph-based solutions. A typical metric-based solution constructed the embedding of the whole trace by predefined metric and then apply some classification model like clustering to find the anomaly. But the generality of a solution is limited by the design of metrics. The sequential-based solution mainly focuses on the sequential representation of trees and utilize the sequential models like LSTM to predict span behavior. Instead, the graph-based solution utilizes graph models to learn the distribution of traces. However, it cannot handle trace evolution like span changes or new emerging spans, which is very common in the cloud scenario. To address these limitations, here we propose TraceLingo to localize the suspicious spans instead of modeling the call path information only. TraceLingo adopts a tree-based RNN model to capture the dependency between spans of various traces, and will learn the trace behavior when the application is running normal, then to test a trace when the application has performance regression by comparing their trace embeddings. And the attention mechanism is used to finally localize the suspicious spans. Here is the details of trace representation. First, we represent a span using both the temporal information and associated contextual information. And as mentioned before, the context in which the trace is executed is highly relevant to the span behavior. Then, the tree LSTM is adopted to learn the graph structure of trace, and a mask layer is used to deal with the various number of spans of different traces. And since the true label of each trace is not available, we use autoencoder to learn the trace when application runs normal in an unsupervised way. Here is a case where TraceLingo is applied. To ensure the VM creation performance, the P99 metric of end-to-end duration is monitored. And once an anomaly occurs, an alert field we collect the trace 1 hour before the alert for testing and sample about 10,000 traces where the application performs well before the alert for training. And in this case, TraceLingo reported about 20 anomalous spans for developers to check. And after investigation, developers find three spines are totally new emerging functions and contribute most to the performance issue. The new appearing spines are brought by a new deployment of one service component, and the other spines show certain degree of anomaly in the execution time. And this shows the capability of TraceLingo in effectively localizing the suspicious spines and also handling the new emerging executions. And in the future, we will conduct extensive evaluation on more cases. Thank you. Any questions?